So in this question 24, question 24 tells me that it'll probably be a little bit challenging because it's one of the last ones of the finance section. So May invests in an annuity and that earns an interest rate of 5.2 per annum. So I'm seeing that it's I, and it says compounding monthly. So I know PPY equals 12. And she receives monthly payments are received from the annuity. Okay, so the balance of the annuity will be this much after 5 years. So what they told you that, they're pretty much telling you that's an FV, that's how much the balance will be when you have 5 years. So would N be 5 times 12? Yeah? So, and then they tell you, they give you another scenario, and then they say the balance of the annuity after 10 years. So you sort of got a FV there after 10 years. So we might say N is 10 times 12 is there. Now you've got to try and find the monthly payments, is what it says. The monthly payment that May receives in the annuity is closest to, so payment. So if I go and write out in Finance Solver, if I write down the things I need to have to solve things, now PMT, that's the question, isn't it? For sure. Yeah, so I can see that that's the question. FV and what comes after that? PPY and CPY. All right, so if I have a look at what I've got, I definitely know the interest rate is 5.2%. I know PPY is 12 and that is 12, and thing is the question. Now, can you see up here if I do my first scenario, all right, I know when it's 5 times 12, I know the final value is 130,784.93. But can you see I'm still missing 2 things, aren't I? So still don't have 2 pieces of information there. I can only use Finance Solver if there's one thing missing. So it's missing there. And you can see if I did the blue scenario, and when it's 10 times 12, and all this would be the same, it's the same thing. I have these 2 missing, even though I have that. So what you have to do is think, well, what do I have? If you think about it, you have what happens between the 5th year. I know if I start from 5 years and go to 10 years, I know what's happened. So what about if I decide to make this one, I'm going to make that my PV, like my starting point. And then if from 5 years to 10 years, how many years is that? So if I go from 5 years to 10 years, how many years will that be in between there? It'll be 5. So I can say N will be 5 times 12 as well, isn't it? Yeah? Can you see that? There'll be 5 years, I know. And what I'm going to do is I'm going to change this one and make it my FV. At the 10-year mark, I'll say that's what it is after 5 years. So what I'm going to do is I'm going to pop into Finance Solver. I'm going to say for those 5 years at an interest rate of 5.2. So when I first knew what something was about, I'm going to put 1. Now it's negative, isn't it? So I'll put negative 130,784.93. I'm going to pretend I invested it at that point, and that the payment is the question I want to know. Now FV will be what the value is after that extra 5 years, which would be the 10th year value, which is 66,992.27. Now that's a positive number because the bank needs to give me back my money. So that's positive, and PPY equals 12, and CPY is 12. Okay, so we can see now that this is our only one we don't know, and you'll pop that into Finance Solver. So let's go do that and see what we get. Okay, so we found that on Finance Solver, we found that to be 1,500. Good. Okay, so today we're going to look at perpetuities. So perpetuities is still similar to an annuity, except there's a little bit of a difference. So a perpetuity, you're going to invest in the bank, or someone's going to invest into the bank a sum of money. So say, for example, you might be talking about, say, someone's grandfather says, so they've retired and they've got this big package of super, so they might decide, I'm going to invest 100,000 into the bank and get interest. And so what they're going to do is that 100,000 will make interest. So, but the difference with a perpetuity is that you just take the interest that you make off it out as a payment. So what people often do, so say, like I said, that grandfather, he might invest it and then he might say, give it to his grandchild and say, here, you can have the interest that this account earns. So at the end of the day, the grandfather's not losing out on his 100,000, is he? He still will have that at the end of how long he wants this to go for, but and then you can get a wage off it. So it's sort of like, it's the opposite to, you remember we had an interest-only loan where we only paid the interest? Well, this one's an investment where we're only going to take out our extra and we do it. So a lot of universities do it. So people donate a huge amount of money to a university. So universities put it in an investment and then they use the interest they make. That becomes the scholarship that they offer to students, yeah? So they'll say, well, we'll pay, and that's the scholarship money is what has. So they're not really having to fork out their own money there, are they? They're not losing out, and that's what a perpetuity is. So it looks like that, and let's go and write what a recurrence relation for a perpetuity would look like. It will still look like. So you would have your VO, which would be your initial investment amount. Okay, and then you'll have, if you had a VN plus 1 rule, it will still be, you'll get R times your time before, and then it'll be minus D. Now, the difference is this D here, will be the interest made per period on the investment, yeah? And this R here, if I do the R will be found by doing 1 plus the rate per annum over the period over 100. So really that interest rate that you're getting will match the thing. So the balance of the perpetuity will always remain the same. So if you had a bank statement, it would be exactly the same. So if you're thinking about your finance solver, FV and PV will be exactly the same, except that when you invest the money, it will be negative. So PV will be negative, but FV will be the same number, but positive. So we'll do a few examples. All right. Okay, so let's start this. So the interest rate for the perpetuity is 6%. So there's my I per annum. What will the monthly payment be? So here is payment. So down here, I'm working out, I've worked it out manually using the recurrence. So if you look at it, I want to know what D is. And here, this form. So D actually works out being R over PPY, you might need to write this, over 100 times the VO. Okay, so that's what I'm trying to do there. I think some things have got cut out. So we would have done 6 over 12 over 100 times 500,000. And that equals 2,500. Now I could have done it, and I probably would be doing it this way if it was me on Finance Solver, because you get so used to all these questions and just always using Finance Solver, we may as well use it. Now with Finance Solver, you only need, I want the payment is the question. So all I'm going to do every time, every period, or every payment is exactly the same, because like what Cruz said before. So it's always the same. So we can just work out one payment. We'll just do that. And we'll say the interest rate, which was 6%. PV, I'm going to put negative 500,000. What comes there? Payment, but that's the question. FV is where I'm going to put the positive one, because they always remain the same. And PPY equals 12. So you'll do that and you end up with 2,500 there as well. So same way. Okay, a university mathematics faculty has 30,000 to invest. So here we got 30,000. It intends to award an annual mathematics prize of 1,500 with interest earned from the investing. With the interest earned from this investment, okay, in a perpetuity. So now I know that this is perpetuity. I'm going to say this is my PV, and that is a negative, and it'll also be my FV as well, which will be a positive. When they tell me that the prize is going to be 1,500, I know that's a payment. Now the payment is also a positive, because you'd be getting it back from the bank, won't you? It's a payout, yeah? And we know, did it tell you how often this payment was going to happen? I think it did. How often is here? What does annual mean? Yearly. So what that's actually telling you is PPY is 1, okay? So with the interest earned. So what is the minimum interest rate? So really, in the end, I is your question. When you see what, you know that's the question. What is the interest rate? So you can see I put it all in there. If I show you, if I show you 1, so we're putting the N as 1 into there, because we only need to know one payment. And here's where I put the negative, positive, 15, and PPY as 1. And the answer, I pressed enter there, and I got 5% was the minimum I need to use. Okay, so we've got another one underneath, so let's do that one together. It says, a charity fund wants to set up a 2,000 annual scholarship. They are able to get a financial institution to offer a long-term interest rate of 5% per annum. The amount PV that needs to be raised by the charity is. Now, if I don't know what PV is, so if you look there, PV is the question, but when it's a perpetuity, which is what this scenario is, I also don't know what FV is, because they're the same. So I can't use Finance Solver because there's two things missing, yes? So I need to find that out. So I'm going to use that formula before. Remember I said the D, the payment that you make, was the rate divided by PPY over 100 times VO. Now I know what D is, that's here. So I know that's 2,000. And you also know that it's 5% and PPY is 1 over 100. Now times VO, I might just say times X. That's what I want to know. And I'll do solve. And in the end, that X or VO is what you initially invest, isn't it? It's PV. So let's go do that. Okay, so we got X equals 40,000. So therefore, VO is 40,000, or we could say, or the PV, the initial investment, was 40,000. Okay. All right, a scholarship will set up an annual prize of $400 to the best mathematics students in the school. The scholarship will be paid by investing an amount of money in a perpetuity, at 3.4% per annum, compounding annually. So I just got told a few things. I got told that's payment, and that's a positive because I now know perpetuity. So you might just write that PV, negative PV equals FV. So they're going to be the same. Here's my I, and compounding annually. So PPY equals 1. The amount needed to invested by this scholarship would be, now this is the same as the question we just did before, isn't it? So I can't use finance solver, so I'm going to do, so D equals payment, and we knew that R over PPY over 100 times the VO equaled the D, yeah? And then so we do it exactly the same. So we've got 3.4 over 1 over 100 times X equaled 400. Solve, comma X, and what do we get X to equal? I've got 11,764 actually got 0.7, but it's saying closest to, so I'm happy to say that one. Okay, let's do the next one. Samantha inherited $150,000 from her aunt. She decides to invest the money in an account paying 6.25% per annum interest compounding. If Samantha deposited money into a perpetuity, what are the monthly payments she would receive? So here, this payment is the question, and we have everything that we need. We're just going to put 1, the interest rate is 6.25, PV is negative 150,000, payment is the question, FV will be positive 150,000, and PPY equals monthly, so 12, yeah? Off we go, and we do that one. Alright, so we got the payment to be 781.25. Let's do the next bit. If Samantha deposits her money into an annuity, this is different now, and withdraws 1,000 per month, how much would she have in her account after 1 year? Okay, so we've got some different scenario happening here. So I might just do it down here. So N is after 1 year, but it's monthly. Interest rate is still 6.25. PV, she's still investing 150,000. Payments is she's going to get a positive 1,000 a month. FV is the question. They want to know how much money is still left. And PPY equals 12. So here's the answer to that one. Let's go work that out. Okay, so when I pop this in here, I get N to be 37.2. So I'm going to say that's when it would reach 100. So I'm going to say after 38 months, yeah? You're going to go up. If I go down, I'm not at 100, so I've got to go over. So I'll just round to the nearest month. I'll just say, so after 38 months. And if you have to change it for years, you just change it divided by 12, yeah? Okay, so let's do the last one here. Samantha deposited her money in an annuity and withdrew 4,000 a month. How long will her investment last? So this is N is the question, and we go through the same thing. It's still 6.25. PV still negative 150,000. Payment now is a positive 4,000 a month. FV will be, now it's saying how long will the investment last. So if you're going to exhaust the investment, what will FV be? 0, good. And PPY equals 12. So you zip that one in. Okay, so I got it to be 41.8. So how long will her investment last? I'm going to say 41 months, yeah? or 41, because she's not quite going to get 4,000 on the last payment, is she? So maybe just say 41.8 months and be safe, yeah? Because if you write 42 months, she's not quite going to get the 4,000 in that next one. They'll be a little bit more clearer in your exam and make it more nice and neat up for that. So including interest, what would the value of her last payment be? So can you see that she's not quite going to get there? So let's see what she owes at the end of 41 months. So if I'm doing this question, let's put in 41 months and interest, 6.25, PV, payment, 4,000. Let's find out what this FV is, and that will be in her last payment. Depends if you're going to go reduce the next one or add on to it. But so that's not very clear, so they need to be a bit more clearer, and they will be in the exam. So let's go do. When we do that, we get 3,005.85. Yeah. So she could either have that extra, or in the next month, she would have a reduction. Yeah. So, I don't know how to say that name, Juanita, invests 80,000 in a perpetuity that will provide 4,000 per year to a scholarship fund. The graph that shows the value of the perpetuity over a period of 5 years, does the value change in a perpetuity? No. So what it would just be whatever it is straight across, won't it? Yeah? Bonus. How easy was that one? That was question 21. I remember the year they did that. Lots of kids got it wrong. It's a bit sad. Anyway, which one of the following recurrence relations could be used to model a perpetuity investment after n months? So can you see how they've got, the way you're going to work this out is this bit is the D, and it would have to equal the interest that you gain. So if you do this number times the PO, you should end up, so if I do that, what I'm saying, if I do 120,000 times the interest rate, which is this bit, the 0029, it should equal 356 if it's a perpetuity, because the interest has to equal. So we're going to have to do them. Is that what you're saying? So this equals 348. Is that number there? No. So you do it in the next one. You've got, oh, sorry.
Shouldn't it have a 1?
No, we're just trying to find the interest.
Yeah, but
the interest part.
0.00.
Is it, yeah, so the 0.47, the extra bit is the interest, the bit above 1. So if I do 180 times 0.0047, what does that one equal? This one equals 846, which they said was there. So I'm going with B, and I'm moving on. So for an exam technique, move on, come back. If you've got time to check, you would check these ones. Make sure they don't work, because you're then checking something different. You're not doing your work again, because if we made a mistake, we often do the same thing. Yeah? So try to check a different way. That's a technique.